سلايد رقم كام؟ 25. Okay, great. So, are you able to see the slides? Okay, great. So, we talked in the previous lecture about the well-known meta-heuristic called genetic algorithm, which is an algorithm inspired from the genetic phenomenon. And we illustrated the example of the knapsack and how to represent a chromosome for this problem, and how we can generate generations by taking the best parents to cross them between each other and to get a new generation, which have to be in good health. So in slide 25, we are talking about the limitations of genetic algorithm. So using genetic algorithms don't guarantee an optimal solution. So this does not guarantee an optimal solution. Often settles in a suboptimal solution or local minimum. Not all problems can be put into genetic algorithm formulation. It's not easy to put any problem in the form of chromosome in general. Development and interpretation of genetic algorithm solutions requires both programming and statistical skills. It relies heavily on the random number generators. Locating good variables for a particular problem and obtaining the data for the variables is difficult. Selecting methods by which to evolve the system requires experimentation and experience. Some applications for the genetic algorithm will find the dynamic process control, the optimization of induction rules, discovery of new connectivity topologies, simulation of biological models of behavior, complex design of engineering structures, pattern recognition, scheduling, transportation, and routing, layout and circuit design, finally telecommunication, graph-based problem. Let's talk now a little bit about simulation. Simulation, that's when you want to simulate a problem by some parameters and you want to see the results, the effect of the values of your parameters on the final solution. So simulation is the appearance of reality. It is often used to conduct what-if analysis on the model of the actual system. It is a popular decision support system technique for conducting experiments with a computer on a comprehensive model of the system to assess its dynamic behavior, and often used when the system is too complex for other decision support system techniques. Okay, you have case study. Major characteristics of simulation. It imitates reality and captures its richness both in shape and behavior. Technique for conducting experiments. Descriptive, not normative tool, often to solve very complex systems and problems. So we are using the simulation, especially when you have a really a very complex problem that you cannot modelize, for example. Simulation should be used only when the numerical optimization is not possible. Sometimes it's not possible to optimize, to write the mathematical model. So in these cases, you are requested to use the simulation for complex problems. Advantages of simulation. The theory is fairly straightforward. Great deal of time compression. Experiment with different alternatives. The model reflects managers' perspective, can handle wide variety of problem types, can include the real complexities of problems, produces important performance measures, and often it is the only decision support system modeling tool for non-structured problems. One of the most well-known unstructured problem where we have to take decisions, which is the traffic red lights. So you will simulate the red light to find the optimal and the best value of seconds in each direction. Advantages of simulation cannot guarantee an optimal solution. Okay, so we don't have the optimal solution. Slow and costly construction process cannot transfer the solutions and interfaces to solve other problems. So it is problem specific. كل problem عنده صيغة السيموليشن بتاعه. So easy to explain and sell to managers and may lead to overlooking analytical solutions. So this is very easy when you want to sell your product, your simulation product. Just show the manager a simple example of simulation and he will be compensated directly. And this will maybe overlooking analytical solutions. When you are using simulation software, maybe you are required to have some special skills. Simulation methodologies. These steps are fine. 1. Define the problem. 2. Construct the model. 3. Test and validate the model. 4. Design experiments. 5. Conduct experiments. 6. Evaluate the results. And 7. Implement the solution. And here you have the processes. Once you implement the results, evaluate the experiment's results, and then you will implement the results, then you will change the real world, okay? And then you can define again the problem, construct the simulation model, etc. So it is iterative, it's a cycle. Simulation types, there is the probabilistics and the stochastic. حتى أنا. النت عندي ضعيف بسبب الأمطار. ترى ما في أمطار الحين. طيب, are you following me? Everything is okay now? Okay. The simulation types, that is the probabilistic versus and the stochastic versus deterministic simulation. It uses probability distributions. It's time-dependent versus time-independent simulation. There is the discrete event versus the continuous simulation, simulation implementation, visual simulation, and or object-oriented simulation. For the visual interactive simulation, it's visual interactive modeling, also called visual interactive simulation or visual interactive problem solving. It uses computer graphics to present the impact of different management decisions. It is often integrated with 3J and geographic information system. Users can perform sensitivity analysis when changing the parameters of your problem, and there is static and dynamic systems. Virtual reality, immersive. Here you have an example of traffic at an intersection from the ORCA visual simulation. So here we are using the software called ORCA visual simulation. So here we draw a cross between two roads, and we can give some parameters here, okay? We give parameters, using these tools that we have in the left and in the right. Like, for example, the number of cars coming, the time of the red light, the time of the green light. Okay, so here, as you see, here we have red light, here we have red light, here we have red light, here we have green light. Okay, so here we have عدد معين من السيارات التي تأتي كل دقيقة وهي تأتي according to the normal form, for example. So you will simulate after 20 seconds, okay, still we have cars coming from the side or not. And let's see. We will simulate 20 seconds from the side, 20 seconds from the side, 20 seconds from the side, and 20 seconds from the side. And let's see what's happening. And then you can ameliorate your decision when you simulate this situation. Another case study, job shop. This is another simulation software which is called Simio simulation software, and this is here we are simulating a manufacturing. Sorry, معمل. فعندنا several machines, okay, and each machine have a capacity of production. والعمل يصير يعني ماشين بعد ماشين بعد ماشين. فبالتالي let's simulate لو تشغل الماشين الأولى ساعة، لو تشغل الماكينة الأولى ساعتين، ايش راح يصير بالنسبة للماكينة الثالثة، ايش راح يصير بالنسبة للماكينة الرابعة. They will wait, they will not wait. So you have to fix some parameters, like for example, then the order number, how many items we are asked to produce, etc. Okay, here more details about the Simio simulation software. More details. Okay. Simulation software is comprehensive list. A comprehensive list can be found at that address. Simio, SAS Simulation, Lumina Decision Systems, Oracle Crystal Ball, Palisade Corporation, Rockwell International. System dynamics modeling. Macro level simulation models in which aggregate macro-level simulation models in which aggregate values and trends are considered. The objective is to study the overall behavior of a system over time as a whole. The evolution of the various components of the system over time, and as a result, of interplay between the components over time. First introduced by Forrester, a wide user technique in operations research and management science. Okay, this is an example of system dynamic modeling. The agent-based modeling, another process for the optimization, the agent-based process, the agent-based modeling. An agent is an autonomous computer program that observes and acts on an environment and directs its activity toward achieving specific goals. It is relatively new technology. Other names include software agents, without, no-bots, both, intelligent software robots, or softbots. Agent-based modeling, or ABM, is a simulation modeling technique to support complex decision systems where the system is modeled as a set of autonomous decision-making units called agents. And there is a bottom-up approach to simulation modeling. And agent-based modeling platforms like Swarm, NetLogo, Repast, or Sugarscape. Application 5, agent-based simulation helps analyze spread of pandemic outbreak. And this is the end of the chapter. Okay, ما راح نطول عليكم اليوم. هل عندكم أسئلة؟ So we'll stop here, and I will take the attendance in the same time. If you have any question, please. It's the right time. نعم عفاف، تفضلي. اوكي، بالتحضير يعني. طيب دقيقة أفتح الليست وأقول لكم. دقيقة واحدة افتح الليست. عفاف أبو عيشة. أحلام خضراء. أحلام غير موجودة. عالية خوجة. طيب خلاص، تعرف ايش؟ أحضر لكم الكل اليوم، طالما انه في أمطار بحضركم اليوم. اوكي؟ يلا كلكم موجودات. شكرا لكم والسلام عليكم ورحمة الله تعالى وبركاته.